Today we will be discussing the importance of data programming languages in today's career by Ananya, Eric, Brian, and Sarthak. In this presentation, we will talk about the introduction, overview of key languages, importance in careers, skills learned and career advantages, and a conclusion. What is data and data programming languages, and why do they matter? Data is a raw form of information, collection of facts, figures, numbers, or just observations. Data programming languages are computer languages used to collect, process, analyze, and visualize data. These are tools used to communicate with data to organize, find patterns, and build solutions in various areas like business, healthcare, engineering, and more. Like Clive Huddenby said, data is the new oil, but those who can analyze and program with it will drive the future economy. The first programming language we will be talking about is JavaScript. JavaScript is a high-level programming language. This means that the programming languages are used for writing programs or softwares that can be understood by humans or computers. They're easier to understand because they use a lot of symbols, letters, and phrases to represent logic and instructions in a program. JavaScript is also an interpreted and compiled language. This means that the code is executed line by line as well as translated into machine code by a compiler before execution. In addition, JavaScript is dynamically typed. This means that having a defined data type is not required, as the data type is decided and checked at runtime. Why use JavaScript? Being an object-oriented programming language makes it helpful with graphics and visualizations. It can be used to develop and design websites, databases, and applications, interactive data visualizations and diagrams, as well as ML models. It can be used to combine web design and data in ways like fintech or social medias, and can be used in tandem with TensorFlow for automation and developing ML models. A few key features of JavaScript are that it is versatile. It can be used for a variety of tasks ranging in complexity from small calculations to working with the server. It is asynchronous and can conduct tasks like getting data from servers without freezing the UI. It has a rich ecosystem, meaning that it has libraries and frameworks such as TensorFlow, React, Angular, and Vue.js, which are built on JavaScript, and it is an object-oriented programming language, which is a style of programming that uses classes and objects to model real-world things like data and behavior. A few real-world JavaScript applications include web and game development, web servers and applications, data visualization, and machine learning. The next programming language we'll be talking about is R. R, like JavaScript, is a high-level programming language and is dynamically typed. Unlike JavaScript, R is an interpreted language, meaning that the code is executed line by line. A few key features of R include its cross-platform support, which means that it works on multiple operating systems, so it's good for different environments. Its interactive development, it can interact with data to test and see immediate results. Data wrangling, it's good for data cleaning using tools like dplyr and tidyr. Statistical modeling, R has built-in functions for statistical models like regressions, time series analysis, and clusters. And reproducible research. The code and output can be combined in one document so it can be duplicated easier. Why use R? R is free and open source, which allows anyone to work with R and change and share their work. It is designed for data with a main purpose of data analysis and has a set of tools available for statistical computing and graphics. R has a large package repository, meaning that it has many packages that can be used for specialized tasks. Its cross-platform compatibility allows it to be used on Windows, Mac, and Linux operating systems. And the visualization allows it to have easy interactive charts and graphs to visualize data better. A few applications for R include data science and machine learning, finance, healthcare, and academia. For data science and machine learning, it can be used in data analysis, statistical modeling, and ML tasks. In finance, it can be used for quantitative modeling and risk analysis. In healthcare, it can be used to analyze medical data and test hypotheses. And in academia, it can be used for data analysis and to publish reproducible research.
All right, now we'll be talking about Python. If you notice, there are a lot of similarities between Python and the other programming languages, just like the fact that Python is a high-level language. And again, that just means that when you're reading a set of Python code, that specified code will be relatively easy to understand, as it abstracts away from the complexity of computer hardware. As far as compiling goes, Python is described as interpreted and compiled. The compiled portion can be described as the computer interpreting the human-readable parts of the code and changing it to an intermediate form called bytecode. That bytecode is then interpreted by the Python virtual machine and is translated into machine code that the computer can understand. Dynamically typed refers to a programming language where a variable's data type is determined and checked at runtime, not during compilation. To simplify, this means that a variable can hold different types of data throughout the program. Of course, if there are any questions, again, please look at Python's documentations or any other programming languages documentations in this lecture. So these are Python's key features. The first is that it has a fairly easy syntax conventions. So when writing code, the arrangement of things is easy to write and understand. An example of this being Python's inbuilt indentation convention, where certain data structures require the user to indent code, otherwise it wouldn't work properly. This makes it easier for others to understand the code, since there is a set of standards, and this makes it relatively easy to organize said code. Python is also object-oriented, which means that when modeling code, it structures it around objects, which a programmer can make it to where those objects or lines of data have attributes and methods. This makes it to where you can create blueprints to model real-world objects and entities. Python also has a large amount of packages and libraries at its disposal. Python packages, or a set of modules and libraries, are a group of Python functions that carry out specific functions. This oftentimes shortens the amount of code you need to write and makes things simpler. Some common packages and libraries are NumPy, sklearn, and pandas. Python is inherently a cross-platform language, meaning that Python code written on one operating system can typically run on another operating system without modifications, if you go through Windows to Mac, for instance. So why use Python? It contains the following useful things that can help people with data. For one, it's easy to use. It's open source, which means that users can freely use it, that you can look at the source code, that you can modify it, and you can freely distribute it. It is widely used across industries and is very popular, and is constantly being updated with new features as well. This slide is just to mention some of the use cases that you can use for Python, such as for data science, web development, automation, and prototyping. The one other mention of Python is that it's also relatively slow in comparison to other languages due to the interpreting part of Python that needs to go through to compile all the code. So now moving on to SQL. SQL is probably the most unique language on this list due to it being a DSL or domain-specific language. A domain-specific language is a computer language designed for a specific problem domain, unlike a general-purpose language that is applicable across many domains. To shorten, this means that SQL has a specific purpose, and that purpose is to be a relational database. Relational databases allow users to store huge amounts of data and retrieve and manipulate said data. The relational portion of SQL really refers to the keys of the database, where entities are linked through a primary and foreign key. So a query is often used for databases. So a lot of times when a user needs additional information from a database, you can create queries or questions that the database can retrieve from. So a declarative programming that we see on the slide is a programming paradigm that focuses on what a program should accomplish rather than how it should achieve it. So SQL is used for querying and managing data in relational databases, where you specify what data to retrieve or modify, not how the database should perform the operations. That's just referring to the first declarative language key feature. So data definition can generally be defined as managing the structures of the database. It focuses on the schema, which is the blueprint or definition of the database rather than the data itself. Data manipulation language is used to manage and manipulate data within a database, pretty self-explanatory. querying data again refers to the user asking specific questions to the database and retrieving said information. And lastly, ANSI standards aims to provide guidelines for SQL, which helps with consistency and allows portability across different database management systems. So why would you use SQL? Well, for one, the rationale, the relational structure where you have data that has entities that relate to another. Two, for the ad hoc queries where you want to retrieve information from the database. Three, SQL can carry a large amount of data. Four, the simplicity of SQL makes it easy to carry out its functions. And lastly, there are built-in data integrity functions that ensures that the functions and security of the databases are intact. As far as the applications of SQL, here are just a few, such as SQL being used as a backend database, as a data pipeline for other applications, to hold financial records and government files. Now moving on to Julia. Julia has very similar characteristics as Python. The difference, or one of the main differences, is the compiler for Julia, which is just a just-in-time compiler. A JIT compiler translates code into machine code during the program's execution, blending the speed of compiled languages with the portability of interpreted ones. So here are the following key features of Julia. It has an easy syntax, it has fast computation, it's open source, and has high performance. Julia generally could be described as being a higher performance and optimized programming language because of it. So these are the reasons why to use Julia. Its speed, its two-language solution where Julia is prototyped in a flexible and relatively fast system to where you don't need to have multiple languages to use. It's parallel processing, where it's a technique where multiple processors execute parts of a task or multiple tasks simultaneously to achieve greater speed and efficiency. It's interpretability, which be the ability of a computer system or software to exchange and make use of information. So here are the applications of Julia: scientific similarity, simulations, data science, optimization, and prediction handling. Lastly is C++. Without going into too much redundancy, C++ is fairly similar to other programming languages previously mentioned, except it's statically typed. A statically typed language is just where a variable's data type is checked at compile time before the program runs. So here are a couple of C++'s features. So it's low memory manipulation, compiled in high performance. It having a standard template library. It's memory management controls. It's strong type controls. And this makes it to where C++ is generally a fast and reliable programming language for huge projects that need a lot of memory. These are just a few of C++'s use cases, such as its fast computation speed, being able to be used for large projects, it being widely used across industries, and it being a language that controls the memory allocation within its functions. So here are just a couple of C++'s applications: systems programming, game engines, and trading, and being used for large-scale applications. I'll now be passing it along.
Now that we've seen the main data programming languages, you might be wondering how they're actually used. Let's look at their impact across different careers. Importance in different careers. Data skills aren't limited to one field. Business, finance, healthcare, education, engineering, and technology. While connecting the course to careers is important, focusing on industry-based career helps explain why data programming languages like Python, R, SQL, and Java are essential in those fields. Data analyst is all about transforming raw data into meaningful insight. Data collection, cleaning, visualizing, to help organizations understand trends and make smarter decisions. To do their work, analysts require using programming languages like Python, R, and SQL, along with other tools, primarily to identify patterns, build statistical models, and perform predictive analysis. Typically, they hold bachelor's or master's degree in mathematics, statistics, and economics. Examples like companies NASA, Google, and Spotify. NASA used Python to interpret mission data and improve efficiency. Google optimizes data to enhance video processing, while Spotify uses to analyze user data and personalize music recommendation. Financial analysts. Financial analysts combines data skills with financial knowledge to evaluate financial performance and market trends. Education background is bachelor's or master's in finance, accounting, and economics. They primarily use programming languages like Python, R, SQL, as well as other applications to build models to predict market trends, automate trading algorithms. Companies like Robinhood, JP Morgan, Bloomberg design automated trading algorithms, understand market forecasting, and trading risk analysis. Biostatistician applies statistical methods and data programming to contribute to medical research, primarily using R, Python, Julia, and SAS to analyze clinical trials, develop predictive disease outcomes, and support pharmaceutical research. Education background, master's or PhD in biostatistic or statistics. Organizations like CDC, WHO, which relies on programming languages to analyze health data tracking and to turn biological data into insight to save lives. EdTech developer, on the other hand, build and maintain educational systems and platforms using Python, JavaScript, and C to build learning platforms and educational platforms. Companies like Duolingo and Khan Academy use these data skills to personalize learning and educational systems. A software developer. Software developer creates, maintain software applications that power businesses, networks, and devices. From engineering simulation to modeling gaming platforms, optimize system performance and reliability of application systems. Works with multiple languages like Java, C++, Python, JavaScript, and many more to design, maintain, and build a software system. Educational background, bachelor's or master's in computer science or software engineering. Companies like Infosys, IBM, Xbox. Developers design systems for simulation, automation, and user performance. Aerospace data engineer. An aerospace data engineer who uses flight or spacecraft data to improve performance, safety, and mission outcome. Education in engineering, aerospace engineering, data science, computer engineering, or physics. Primary languages used are Python, C++, SQL, and MATLAB to analyze flight data, simulation spacecraft performance, and improve space missions. Companies like NASA, Boeing, and SpaceX are dependent on these data languages programming to monitor engines, launches, and predict risk analysis for spacecraft.
When we think about learning data program, it's not just about technical skill. It's about developing a new mindset for solving problems. The first advantage is critical questioning, asking why before how. In TLT projects, you're trained to dig deeper, to challenge assumptions and identify the real problem before jumping into solutions. That mindset fosters curiosity, creativity, and sharper thinking both at work and in life. Then we move into structured problem solving, turning chaos into clarity. Real-world data is messy. Through TLT, you learn to approach complexity logically, breaking down large challenges into smaller, testable steps. This doesn't just build your technical process, it builds patience, resilience, and adaptability. And lastly, intellectual humility, letting data lead. You learn to stop assuming and start validating. Your conclusions become driven by evidence, not opinion, which strengthens your credibility. This mindset improves decision making, not just for data projects, but any professional or personal situation. So once those personal habits are built, they start to show up in your professional growth. First is data storytelling and visualization, turning analysis into impact. You learn how to take raw findings and translate them into insights that matter. That means designing dashboards, visuals, and narratives that help non-technical audiences understand and act on data. In other words, you bridge the gap between analysis and decision making, becoming the person every team relies on to make sense of the numbers. Then comes on cross-functional collaboration, working across disciplines. Data programming touches every field: healthcare, education, business, and more. In TLT, you practice translating technical work into clear insights from any audience. This builds adaptability, teamwork, and the ability to speak both languages, technical and strategic. These are the exact skills that make you stand out in any professional setting. And finally, all of this builds towards your career ROI, your return on investment. The first piece is a portfolio of proof. When finished TLT, you don't just say you've learned, you show it. You leave with completed projects, reusable scripts, and visual dashboards that serve as proof of your skills. When a recruiter asks, "Show me what you've done," you can literally pull it up. The second is networking and mentorship, the power of the TLT community. Throughout your internship, you're collaborating with peers, alumni, and professionals who share the same passion for data and innovation. These relationships often evolve into mentorship and career opportunities long after the program ends. And finally, focus on innovation and impact, standing out as a data innovator. Your projects don't just show competence, they demonstrate creativity. TLT encourages you to take initiative, build new tools, and bring fresh ideas into any organization. By the end, you're not just a contributor, you're seen as a forward thinker who uses data to drive innovation. So overall, data programming languages aren't just about coding. They're about mindset, communication, and impact. Throughout TLT, you gain the technical foundation, the professional network, and the creative confidence to turn data into opportunity. That's what makes this program and these skills so essential in today's career landscape. Thank you.